Good evening. In many ways, we might characterize the last 12 months or so as the year of the dire climate change report. I, like many of you, have felt rather overwhelmed by the inundation of both national and international climate science reviews. They've begun to outline the fingerprint of anthropogenic or human-caused climate change on extreme weather events. We have a better understanding of how we're forcing changes in biodiversity, increasing rates of species extinction. And we're understanding not only how these things are happening in our natural world, but of course how they're also impacting human civilization, our own infrastructure, and our day-to-day lives. But for many folks in this room, although we're well aware, the average person might not see this reported in mainstream media. Let's take, for example, the IPCC's most recent report. The IPCC, or Intergovernmental Panel on Climate Change, released their most recent special report in November of 2018. It was commissioned, of course, to quantify the probability with which we could limit global warming beneath or to 1.5 degrees Celsius warming above pre-industrial levels. The science there, of course, is not very inspiring, not very positive. So can we do it geophysically? Yes. Maybe. Can we do it politically, socially, economically? Perhaps we have greater barriers there. Here's how that was reported in the media. We have 12 years to limit climate change catastrophe. We have 12 years to act on climate change before the world as we know it is lost. The world has just over a decade to get climate change under control, and the planet, not people, the planet, has only until 2030 to stem catastrophic climate change. So there's a bit of a disconnect here then between what the actual science is saying and how mass media interprets it. How can we properly communicate the problem of climate change, the immediacy of climate change, without being alarmed like those headlines were? We know the psychological effect of those headlines. There's a type of paralysis. It's referred to as emotional numbing. We turn away from the issue. It seems too big, too gargantuan for us to handle. What we really need are proper scientific communicators that can speak to the immediacy of the issue and also inspire action. And I'm excited to introduce Dr. Richard Alley this evening because he's been so successful in doing exactly that. What I like about Richard's work and what I'm so inspired by Richard's work is that he sees the science through. He goes through the painstaking effort of collecting that scientific data, writing those international reports, and communicating it to the broad public like us here tonight, and to politicians and decision makers. So without further ado, to reflect on those more than 40 years of experience communicating the science of climate change and the potential threat of abrupt climate change, I'd like to welcome Dr. Richard Alley.
Thank you. Oh, it is an honor and a privilege to be here. So there's an iceberg from Greenland. 2 days ago, I was on a glacier in Iceland, and so I am happy now to be here. Jillian set up the travel, got me here. Thanks to Rachel for doing this. The Franklin Institute does amazing things, and thank you for coming out tonight. You are an important part of this story, and we'll see what we can do with this. It is a difficult story because it's so wrapped up with who we are and what we do. So we're going to go out for dinner later, and it is conceivable that I will go over my 2,000 calories per day. But a human diet is 2,000 calories per person per day. If you put 2,000 calories, your cheeseburger, well, your yogurt, and you burned it over a day, it gives off the same amount of energy as one old light bulb. All of your brilliance, all of the good things that you do are done with the energy of one old light bulb. You're better, right? If I had to ride my bicycle to make the electricity to run the bulb, I would be out of breath. But I don't. And I didn't get here from Iceland by riding my bicycle. And I did not spend all summer hoeing corn, so I didn't starve to death this winter. If you take the energy that's used in the US economy and turn it into these units, it's 200,000 calories per day. Each of us has the equivalent of 100 people doing our bidding, and we love it. Don't kid anybody. Right now, it's 83% fossil fuel, more or less. and that makes CO2. You know what trash looks like. In the U.S., per person per year, we throw away at the curb for a trash collector a half a ton. And we throw away in the atmosphere 16 tons of CO2. And if you load 16 tons into the atmosphere, what do you get? You get a new climate. The warming influence of CO2 was known in the 1800s, not the 1900s. It really, the modern quantum mechanical understanding was done by the Air Force after World War II because CO2 absorbs infrared. And the sun heats the Earth and it sends infrared to space. And the enemy bomber has infrared too because it's hot. And if you want to build a heat-seeking missile to protect your cities from the enemy bomber, you have to understand radiative transfer in the atmosphere. And in some sense, if you deny global warming, you're denying that the Air Force knows how to target a heat-seeking missile. This is physics, it's physics, it's physics. We don't believe in global warming any more than we believe in physics or we believe in gravity. It is. Now, I did the UN IPCC. I helped the UN many times. This is the mother of all committees. Its first report's 1990. There's 3 working groups. There's been 5 reports. Each report is about 1,000 pages. If you took that 15,000 pages and turned it into a tweet or two, it would be this. We could go ahead and ignore our science. We could pretend that all of this science is done by evil people who are trying to take away your pickup truck. But if we use our knowledge, we avoid being depressed by this, and we take our knowledge and use it, we get a bigger economy. The Nobel Prize in Economics this year was for work showing that dealing with climate change helps the economy. We get more jobs, not fewer. We improve our health, we improve our national security, and by the way, we get a cleaner environment that's more consistent with the golden rule. If we use our knowledge, that's what we get compared to ignoring this. And that's the key point to take home right now. Using our knowledge with respect and commitment makes us better off, right? Now, I've been doing some of this for a long time. That's me on the right up there. In 1978, working in Antarctica. This is me going to Greenland. I was in the field on our first wedding anniversary, and our 5th, and our 9th, and our 10th, and our 12th, and she's still married to me. I don't quite understand this. But at any rate, this is Greenland. We are in the middle of Greenland. We are on 2 miles of ice. We are 200 miles from the nearest rock. This is midnight on the 4th of July. And here's Wanda Kapsner, who's now a teacher and runs a winery, and she's studying ice. And here's Kurt Cuffey. He's now a professor out in Berkeley, and he's studying ice. And I was up to Iceland with Sridhar, and he's studying ice. And if you ever study ice, you know, after a month, your socks take on a life of their own. So this is freeze-dried laundry. We're working on it. When I took this picture, we had been there for a month when I took this picture. The newspaper was a month old, but it was actually functional. I label this a good day in Greenland because the wind blows, and this is a bad day in Greenland. In case you have to go in a hurry. Yeah. Okay, so what I'm going to do, here's Joan Fitzpatrick and I, that's me there. We're digging a hole. We're going to put a board over the hole. We're going to crawl in. We're going to look at the layers in that wall of snow, and there they are. And that's a winter and a summer and a winter and a summer and a winter. And now what are we going to do? We're going to drill an ice core. Here's Catherine from Alaska in the big boots, big science. And here's me studying ice cores in a freezer. There's an ice core. And here's the ice core that I'm studying. And what do you know? Well, there's a winter and a summer and a winter and a summer and a winter. And wow, this is tree rings going down. And what do? We can date it by counting layers. How thick a layer is how much it snowed. There's dust in there, there's sea salt, there's pollen, there's micrometeorites, there's indications of cosmic rays coming down from space. There are indications of past temperature. There are bubbles that have samples of old air. and they're all there together. And so we can go into that, and then we work with lots of other people. Rachel used to work on these things. Before she became a great communicator, she worked on these things. And so we and many other history of climate people can do this, and we reconstruct what is the history of the drivers of climate. How did the sun change? When did the volcanoes block the sun? What are the orbits doing? What did the climate do in response? Cause and effect. How are they related over time and space? And we can ask, do our models, does our physical understanding, does the Air Force get it right? Okay, and we do this without cheating, and we do, okay? So what do we do with that information? Here's a glacier in Greenland. What do we do with that? You know that the hills around Los Angeles have always burned, and that means that the hills are burnable. So if you saw a kid going up there with illegal fireworks some dry summer, you might call someone. You know that people have always died, and that means that we can die. So you see somebody going by with a gun, you call somebody. You probably know many people who say, well, climate has always changed, so we shouldn't worry. Could you imagine a sane person saying people have always died, so we shouldn't worry about somebody aiming a gun at you? Or someone saying the hills have always burned, so we shouldn't worry about people lighting fires. And yet routinely they say, well, the climate has always changed, so we shouldn't worry about it. Right? This makes no sense. Right? Climate has always changed. That proves that climate is changeable. Climate change has always affected living things. We often learned about the change by seeing what it did to life first. That proves it's important. When we do all of this science, I just finished a whole semester teaching the next bullet. It took us a semester to do the next bullet. Climate has changed, but especially CO2. We humans could make changes as big as sort of the biggest things that have happened in the entire history of the Earth and faster than virtually all of them. That's what's on the table right now. And if there's any problem with our physical understanding, the Earth is a little more changeable than the models. Okay? So here's some data. This is today over on your right, and that's 5,000 years ago. I helped do this. This is temperature in Greenland, not the whole world, but it's in Greenland. And there's some wiggles, and the last wiggle, we're now up in here someplace, but the last wiggle has names because it affected people. And so there's the Little Ice Age. And we understand that. It was a little bit of sun, a little bit of CO2, and some volcanoes blocking the sun. And then I'll show you this. When the Ice Age ended, it was a lot of CO2 and a lot of orbits. And when the Ice Age ended, sometimes the climate changed smoothly, and sometimes it staggered. And that's about 18 degrees Fahrenheit in about 10 years. It was different in different places, but pretty much everyone on the Earth got a new climate at that thing. It was a jump. And there's sort of a lesson in there. When you force climate to change, sometimes it just changes, and sometimes it jumps and staggers and does crazy things. Okay? It actually turns out humans started agriculture as soon as the jumping got done. We couldn't really be what we are in a world with jumps. So that's an interesting aside. Jumps. We are warming the Earth. I was on a glacier that is very clearly melting back. Virtually every glacier on Earth is melting back. That raises sea level. We're expecting 3 feet of sea level by 2100. If we don't change our ways, it could be 2, it could be 4, it could be 15. I don't know what you do with the Philadelphia airport at 15. I honestly don't. But the uncertainty is a little better, a little worse, a lot worse. There could be big, fast changes. It could stagger. Okay? So that's out there. The harder you push on something, the more likely it is to stagger. If you were to just push on me while I'm walking, I can sort of veer easily. If you shoved me, I might stagger or fall down. If you push the climate hard, you might trigger a jump, and a big, rapid jump, an ice sheet collapse, losing the Brazilian rainforest, losing a country that has a civil war is way more expensive. Slowing down takes out insurance against abrupt things. The The truth is, we're sort of saying it'll be okay. We'll use our knowledge and we won't get screwed. But there's a slight chance that we'll get screwed. And if you want to take out insurance against things, you'd probably slow down even more than the IPCC is telling you. You don't quite trust us, you probably want to slow down. So I'll finish with this. This is where we hit earlier, but this is it. The big picture, the whole picture. What some of you do, what you do, what a whole bunch of people do. If we use our knowledge with commitment and respect, we get a bigger economy, we get more jobs, we improve our health, we get greater national security in a cleaner environment, more consistent with the Golden Rule. Thank you.
Thank you, Richard. I hope you now all understand why I'm so inspired by Richard's energy and enthusiasm. Please submit your questions. You can do this via Twitter or via our email. You can email speakerseries@fi.edu or #talkfi on your Twitter account, and I will manage those up here. So one thing I'd like to point out there, Richard, is when we hear a lot about climate change science, and we bring in a lot of communicators like this, of course, the museum, and in our own climate change education program, CUSP, whom we have a lot of visitors here from tonight. Thank you. We don't often hear the term golden rule. You ended there on more consistent with the golden rule. Why is it important for you to have a climate change science and communication talk that's anchored in more consistent with the golden rule?
Yeah, I mean, I think all of it, I can't imagine that any of you would be here unless you believed in the golden rule. You come at it from different ethical backgrounds, different religious backgrounds. I'm a Methodist, right? We go to church on Sundays when I'm not traveling. This is serious, right? And there are some of us, and probably some of you, that actually sort of think that your immortal soul depends on you doing the right thing. When we look at climate change, who's changing the climate? Rich people in cold places. Who's being hurt? Poor people in hot places and everyone who isn't born yet. And if you look at the golden rule and you say, who's winning? Me. Who's losing? Everybody else. And can I sleep at night? I mean, there are days that this gets hard, and you know this, right? And you have worked very hard on this, but this probably bothers you too.
Oh, undoubtedly.
Right? And it probably bothers all of you because we're here. This is an interesting thing, though, is that the discussion wanders in so many different directions. But the short-term gain of using fossil fuels is going to change the climate for 10,000 years. It's going to, all future generations are going to have to deal with this. We can see a world under full speed warming. We don't use our knowledge. By the time our students are old, places on Earth start to become fatal outside. You go outside, you're naked, you're drinking water, you're in the shade, you're in the wind, and you die of heat stroke. And that is in our students' lives if we don't use our knowledge. And that lasts for 10,000 years. You know? And so you get to this point of, and one can say economically, well, we'll make a lot of money and then we'll give that to these poor people in hot places, but will we? And do they really want to live inside in an air conditioner and they can't go out part of the time?
Sure. It's an excellent point, and it is certainly a point that keeps me and many of us here, I'm sure, up at night.
Right.
But you've been doing this a long time, and it's not necessarily an argument that keeps many others up at night.
Right.
So how do we grapple with that when there are so many vested financial interests?
Right. So it is. There's a report out. We were chatting a little earlier. There's a report out from a private investment firm called Lazard. And I don't know anything about Lazard, but they claim to be the largest private investment bank in the world. And they said that even if there were no subsidy for wind and sun, right now the cheapest electricity to add to the grid in most of America is renewable. It's wind or sun. And all of a sudden, there's 300 million ratepayers in the US that have an economic interest in this.
Sure. And the example that we used, of course, was the mailbox money. Could you explain that story?
Right. Lots of farmers are hanging on by their fingernails. Lots of farmers are losing. And you go to some parts of the world, and this particular story came from Texas, but you go to some parts of the world, and they're folding up, and they're giving up, and they're leaving. And then you'll find these prosperous pockets. They rebuilt the high school, and people are doing okay. And you start asking, well, what's going on? And the prosperous pockets often have a wind farm, a big one. And the ranchers talk about what they call mailbox money. You go out to the mailbox, and there's money in it. And that's a wind turbine, it's $5,000 a year, and there's one next to it that makes 10, 15, 20, 25, 30, 35, 40. 5% of the ranch in wind, 95% of the ranch that doesn't pay as well, and what the ranch always did. And we met some people who didn't quite believe the climate science, but oh boy, did they believe in wind, because it saved the town. It saved their ranch, they're making money, and it works. And there are options coming for farmers to not just do wind, but they may do sun. There are certain crops, if you ever go to the seed rack at the store, and you look at it and say, what does this want? Full sun? Well, no, this one wants part sun. And this one wants part sun, and this one wants part sun, and this one wants part sun. And there are certain crops that you probably will grow more if there's solar cells over your fields.
It's outstanding. We also talked, and this is fascinating, you've been so successful working interdisciplinarily. And so you've worked on these economic projections. And we're sort of dabbling on that here in the example of sun and solar, but what do the economic projections tell us, whether we address or do not address some of these worst impacts of climate change? And I'll pause and sort of revert back to something you mentioned earlier about the Nobel Prize this year, of course, was to William Nordhaus on his work with the DICE model, which attempts to pair climate projections and economic projections, essentially. And now, you've worked quite closely with William Nordhaus.
I have. We co-authored. We were on a committee together. Amazingly brilliant person. And he built these models, integrated assessment models, and essentially you have a choice. Yeah, it's a society. She knows all this, right? So we have a choice as a society. We can consume now, make ourselves better off, use our money for whatever we want now. We can invest broadly in the economy. Or we can target our investment to do particular things. And you can use these models to ask, is that targeted investment worthwhile? And it might be curing malaria, and it might be going to Mars, and it might be dealing with climate change. And right now, every serious study in the entire field says that we are being economically inefficient by not investing in climate change. That the damages of climate change become expensive enough that it pays to put some investment now in dealing with climate change to make the economy bigger.
And is that the case both in the US and internationally, or is it predominantly in areas that are still developing?
Right, so this actually does apply to us as well as the world. It works better if sort of everyone gets on board together. So it is always the case if one country goes and works on something and everybody else doesn't, you get the climate change from the others. You will still occasionally hear the argument, why should we do something when no one else does? But in fact, everybody else is now in a treaty that says they're working on it. So the idea that we don't want to go alone, we led everybody else to the table and they all agreed to do something. Sure. Whether we will is a good question, but at any rate, and this is real economics. This is standard economics. This is, you're going to change the climate for 10,000 years, but we're only worried about the damages for the next 30 or so, because then economic growth is guaranteed, and your grandchildren will be hugely rich, and they can solve all the problems you leave them. If you don't believe economic growth is forever and all the time, you would take more action now to worry about climate change.
Sure. So we went off on the policy discussion quickly, and I'm excited. We have an audience question regarding this. And this audience member says, today I was in Harrisburg to introduce visionary legislation to combat climate change. We want PA to follow other states like Hawaii, California, New Mexico in committing to going 100% renewable energy by 2050. What are your thoughts on bold actions like this one?
Yeah, so This is a way forward. It is very clear. It helps us. It's not going to be easy. And so I applaud, I cheer, and then I just caution a little bit that if we set off to total renewable by 2050 and we make it to 80%, we probably should not consider ourselves failures. And it's we need to find that route of practicality and aspiration. And it is, in the modern communications world, this is really difficult. Because when you aspire, people say you'll never make it. And when you're practical, people say, but you're not reaching for the stars. And somehow there should be a way that we can reach for the stars while being practical at the same time. That's an opinion, but.
Sure. One question I get, I didn't think it would come up this early, but one question I get a lot when we're talking about renewable energy policy is what flexibility around that language there is. For example, renewable versus clean energy. Of course, in the state of Pennsylvania, we talk a lot about nuclear energy and whether or not that needs to be a part of the mix. Is it a reality? Is it a hard reality that we don't want to accept? Is it something we should turn away from entirely? So while we're on the topic of policy, do you see a role for nuclear in future policies like this?
Yeah, so the nuclear, so full disclosure first, my brother is a retired Coast Guard officer who now works for the Nuclear Regulatory Commission. So my brother is great. They are doing good things. I am proud of what he does there. So that probably makes some conflict of interest from somewhere for me. Right now, nuclear is having real trouble economically. And there are bills in Harrisburg to subsidize nuclear energy because it's clean and also because they can't. Right now, it is hard to run nuclear energy as cheaply as it is to build and run new wind and sun. And so there's a real economic difficulty coming here. In addition, it's very clear, in a room of people who are on board with the science, they accept the science, they know what it says, they are looking for solutions, they want to move forward, they want to know what to do. When you bring up nuclear, it is the question which is most likely to start an argument. And personally, I don't think it can ever become a big piece of the solution as long as it is the thing that is likely to start an argument. My gut feeling is that since it's built, since it's running, since you're not changing the waste profile hugely, because so much of the waste is going to be it when it's done, that probably keeping them running has some advantages, and certainly the ones that can be done economically and safely with their neighbors. It isn't absolutely 100% guaranteed that shutting them down is that much safer. They're still there. Right? So there are some good things to be said. I am not endorsing a particular bill, be very clear, but there are some good things to be said about keeping running what's going. But I think there's a big gulf between us and nuclear growing to be any significant chunk of a solution long term.
Sure. And do you think that's the case nationally again or internationally?
I think it's the case nationally and probably internationally. That the costs are very hard at this point. China was pushing ahead brilliantly on nuclear, and now they seem to be pulling back some, and cost may be part of the issue. And there's all these questions. You will meet supporters of nuclear who think it's a great idea that we build nuclear and we bomb their nuclear. And you will meet supporters, because the government always carries the long-term and catastrophic insurance. So no private insurance company writes the Fukushima policy. And so the government always carries the long-term and catastrophic insurance. And that in turn means that the government is on the hook, which means that they need my brother, the Nuclear Regulatory Commission, as a regulatory agency to keep people from the moral hazard of doing bad things because they're not on the hook for the insurance. Is sort of, most people who've studied this in the social sciences say that you need a regulatory structure when you have government insurance. And there seems to be a fair amount of overlap between people who like nuclear and people who hate my brother. And I can't make that one make sense. So I think there's a lot of issues that would have to happen, and the rise of renewables has been so fast and so steep that nuclear going forward long term, right now it doesn't look terribly bright. It's, I will not offer, I try not to take sides, I try not to promote policies, but when I talk to students about what major they might want to go into, I have to say that that's not the one that I tell them first.
And that's interesting, you're sort of reflecting how those reports are structured. So all of those reports that I introduced at the beginning of the talk are policy agnostic. And so we reflect on the state of climate science and what we know about its impacts. And now we're starting to incorporate some of those economic impacts as well, as we have a better understanding. But we don't go so far as to recommend policies. The IPCC in particular has been under fire for maybe being a little bit too conservative there. Do you think that's the right way to continue going about the report writing process?
Right, and this is, so Rachel's a scientist who's now a communicator too, and I'm a scientist, and we're voters, and we have opinions, and I actually have an insignia in my pocket, but it's not on here because it's political right now, and it's not on here. And when I go to church, it is, but it's not on here right now. And so I think that some of us have to be apolitical because we live in such a political world. And if every scientist is out there working on policies and working on politics, it becomes very easy for people who don't like the conclusions to dismiss us because of what we're doing. In the same sense, we're all people, we're all voters, we all care deep. Nobody. You did not get a PhD because you didn't care, right? How much time she spent on this and how much pain and agony and sweat and tears and blood to do it, you cared deeply. And as a consequence, some of us really should be doing, and some of us should be getting elected, and some of us, but I think it's important that we maintain a very wide spectrum of scientists in the public eye, because if we get too focused in any one place, it becomes too easy for the political process to dismiss the reality.
I think that's a wonderful reflection. And I think what you just addressed there is something that we're constantly trying to do here at TFI. And it's acknowledging that we are people behind the scientists. And of course, we don't come with zero baggage to any decision or any interaction. So let's slow down a little bit. We went down the policy route, and I could talk about this for hours, but we'll save that for dinner. You are, of course, a geoscientist by training, and tonight we'd like to talk about abrupt climate change specifically. So I would like to shift gears just a little bit and address some of the actual science between abrupt climate change. For those of you that aren't familiar, it's thanks to Dr. Alley's work that we actually have the term abrupt climate change. And we talked a little bit about your work studying and collecting those ice cores painstakingly to help us understand what abrupt climate change actually is. Can you give us a succinct definition of what abrupt climate change is? We often don't hear those terms paired. We often hear climate change, but not necessarily abrupt.
I don't know if I can do this, right? This is climate change, and that's abrupt climate change, right? So it really is. I mean, the Earth system has dials. The world has lots of dials. You turn up a little CO2 and it gets a little warmer. You block the sun a little bit with volcanic ash, it gets a little bit colder. But occasionally there's a switch. And if you think about a light switch, you push on it a little bit, nothing happened. And you push on it just enough and it flips. And there are certain places in the Earth system that this is. And there are a few physical ones. Glaciers. Anybody been to Glacier Bay in Alaska? You've been there. Was it cool? Yeah. Okay, you sail 60 miles up Glacier Bay to see the calving front. When the first European explorers went by in the late 1700s, there was no Glacier Bay. It was entirely full of ice. When John Muir went by 100 years later, it was almost completely open. The glacier was sitting on a pile of sediment that it had built called a moraine, and when it was pushed off of that pile, it couldn't stop in the deep water behind. It had to get to the next high ground, and the next high ground was 65 miles away, so it went 65 miles like that. And so it's sitting here, it's like an army that hangs onto a ridge and builds fortifications, and when you chase them off the ridge, they don't stop in the valley, they go to the next ridge. And so it was hanging on, and then boom, it went to the next one. And that's an abrupt shift. It's a little push that knocked it off. It couldn't stop in the middle. We're worried, usually, Glacier Bay did about that much to global sea level. The ice thinned by a mile up in the middle. But it wasn't huge for the world, and there's lots of these fjords that weren't huge for the world. I was in Iceland for a meeting of a group that's studying one in West Antarctica, and if it retreats off of its stabilizing ridge, rather than a narrow fjord, it opens in this vast interior basin, and it's about 11 meters of sea level if it does what Glacier Bay did. And you shove it off of its stabilizing ridge, and the next stabilizing ridge is 11 feet of sea level away. That's an abrupt change. And you burn a forest in Pennsylvania and a forest grows back. There are places and times that you burn a forest and a grassland grows back. And if we did that to the Brazilian rainforest, it would be a different world. And then the big ones are us. Right? So a drought hit the Mideast. Israel did not have a civil war. Lebanon did not have a civil war. Syria did. Did the drought cause civil war? Well, it loaded the dice to come up civil war. And the least happy country, they killed 500,000 people because, in part, it was a really unhappy country, and then a drought chased all these people into the cities, and they didn't know what to do with them, and they got mad at each other, and they started shooting. It's 500,000 people, you know? And we do that. At some point, we say we don't trust our neighbor, and then bad things happen. And so this business that you push, and usually you know what's coming. The response is smooth, it's slow, it's expected, you deal with it. It's a little more drought, so you take out more crop insurance or something. But then occasionally, the ice sheet collapses, or the forest burns away, or the society breaks into civil war. And we're not good at predicting those.
No, certainly. And again, we're sort of underlining that golden rule necessity. I like that we're bringing it back to that. So we discussed ice sheet collapse as a potential threshold. Are there others that we're familiar with in the climate system that we could see within our lifetime or our future?
Yeah, I hope not. We're not sure. So there's ice sheet collapse is an easy one. There's a whole lot of carbon frozen in cold soils near the poles. And we're cautiously optimistic that when we make it hotter, that will come out slowly, but there's a chance that some of it could come out more rapidly. I spent a lot of time working on ocean circulation changes, and we're cautiously optimistic that when we warm it up, that the North Atlantic won't do anything crazy. If anyone saw the day after tomorrow, that was sort of vaguely kind of inspired by that jump that I showed in the curve up there. Sort of, kind of vaguely. My understanding was that the science advisor for that had once roomed with an actual really good scientist. At any rate, but there are some tipping elements that are possible. There are some things that could happen in the Southern Ocean that might be interesting. And so we're cautiously optimistic that we won't, but worries about big droughts hitting is maybe as big as anything. That are changes in circulation that would cause regional changes, that people would get really hot or get more snowstorms, or you warm the world, but you don't just warm the world, then you change things. Very few people for a little while might actually see cooling, and a lot of people will see more rain, and a lot of people will see less rain, and the average person will actually see more and less. You get, when warmer air has more moisture, when it's ready to rain, it rains harder, but every hairdryer has a heating element but for a reason, and then it dries out faster, and so you get more floods and more droughts. And if you shift from being in the normal rain to in the drought world, that's a bad thing. So there's a bunch of stuff hanging out there that we can worry about.
So I think this is fascinating, the way it manifests in some of those report projections. So the thresholds we just listed off there were ice sheet collapse, potentially. The so-called methane bomb is a term that's been used in mass media referring to thawing permafrost and releasing methane in particular. We also mentioned the overturning circulation in the North Atlantic, so shifts in how the ocean circulates, certainly. And maybe some changes as well in ocean circulation in the Southern Ocean, right? So with some of these thresholds, then, these are what we call the known unknowns, right? There's another term that Donald Rumsfeld, of all people, hatched, the term unknown unknowns. Could you explain to us what the term unknown unknowns are and how they play into some of those future report projections?
Yeah, so is there something that we're completely missing that we just don't see coming that's going to blindside us? And, you know, if I knew what it was, I'd quick write a paper and then I'd probably get cited and get grants and it would be exciting. But so I don't know what there are way out there things, but things that one might worry about. And so far, probably, arguably, the most successful climate change law that was ever passed was our agreement to save the ozone hole through the Montreal Protocol, because it turns out that the refrigerants that were destroying the ozone are really strong greenhouse gases. And they last a really long time. It turns out sort of the more complicated a molecule is, the more greenhouse effect it gives. And some of them were fairly complicated. And if it's different from the ones we have, it gives more greenhouse effect. And they were different from the ones we have. So they're really strong greenhouse gases. And they were made to be incredibly stable, so they worked in your refrigerator and didn't break down. And so they'll last almost forever. If the world gets really hot and everybody goes to air conditioners, and something happened to the Montreal Protocol, so they went back to using really long-lasting, really cheap, really stable greenhouse gases that are bad as refrigerants. These projections of how much warming we'll get are way on the optimistic end. It's not getting fatal just in the really hot places.
So when folks say that we are uncertain, but it turns out we're being conservative. We're erring on the side of optimism, I suppose, here.
I think ultimately we depend on the earth, we depend on each other, we depend on what we've built, we depend on these fantastically complicated things. It's really, you just crank up CO2, it's never going to fix everything. But it might break things. And this is, so somewhere in my pocket here, I have a cellular telephone. Right, there it is. You have one probably. Think what goes into this. I mean, it's fantastically complicated machine and computer chips and GPS and, I can break it by throwing it on the floor. I can break it with a hammer. It's so much easier to break things than it is to build them. And just cranking up CO2 and changing the climate for the whole world is not likely to make the Garden of Eden. It won't build the future, but it might break things. And it's so much easier to break than to build that when you ask where are the uncertainties, it could be a little better than I'm telling you. It's a little worse. It could be a lot worse. We could break things. And just the mere fact of building versus breaking sort of tells you that changing a whole lot in a big hurry is a very risky thing to do.
Sure. So the most basic truth here then around the known knowns and the known unknowns and the unknown unknowns is that, of course, the more we warm the planet, the more likely it is that deeply surprising environmental changes will ensue.
Yes.
At some point, somewhere.
That is fair to say. And the scientists, the IPCC, is routinely accused of being alarmist. I think they focus first on the most likely, and then it could be a little better, a little worse, or a lot worse. And that's not alarmist. The most likely is on the conservative side of what happens. Yeah. Any of you still commuters? I'm sorry. Right? What's a commuter face, right? You go out and you try to drive down 76 and you get stuck in traffic for half an hour. That's the most likely. What's the best thing that can happen? There's no traffic. What's the worst thing that can happen? You get run over by a drunk and you're dead. right? That's sort of the way the uncertainties go on climate change. We are expecting something and dealing with it will make us better off. It could be a little better, it could be a little worse, or we could get run over by a drunk.
So on that note,
I'm sorry.
we have an audience question that I think gets at the maybe getting run over by a drunk analogy. So if you could name one, what is the biggest threat or the worst effect of the oncoming climate crisis?
Yeah. It's probably what it does to us, what it does to our social systems, what it does to climate refugees. So there's a few studies. Climate change already made drought more likely in Syria. We doubled or tripled the likelihood that Syria would have that drought. It had the drought, and Syria melted. And you can see echoes of that climate refugee problem showing up in politics in many places, showing up in how we trust each other and how there's a lot of scholars are looking at this, and they say they can see ripples coming out of did we cause their drought? We don't know. Droughts happened in Syria before, but we loaded the dice to come up drought. It came up drought, that happened. There are scholars now looking at, we are making drought more likely in Central America. A drought has happened. We probably made that one more likely. There are many people fleeing this. They're coming towards our border, and among other things. And you can see the echoes of that in how we get along with each other and what we're doing. And if we really push climate change, the projections, you can check my numbers. I don't quite remember, but I think it was the World Bank, and I think it was 160 million to 100 million people pushed into extreme poverty, and many of them becoming climate refugees in the next small number of decades. So probably the big thing is what it does to us, what it does to our society, what it does to people relying on natural rain-fed agriculture who don't have much money.
Sure. And yet, in the face of everything you just said, there are still folks that refuse to hear that impact. There are still folks that identify proudly as climate denialists. Another audience question here, and I think it's one that's probably on all of our minds, is how we engage with those folks. What successful communication tactics have you employed to really get at those hardline denialists?
Yeah, and there are a few people that probably the best thing is to smile and nod. But most of them actually are good people, and they care about things and they want to move forward. And so some of it is to find out what really is on their mind. And like I say, right now, because the economics as well as the ethics are in the same, the national security are in the same direction, actually finding out what's really on their mind might be helpful. I had this wonderful opportunity to make a PBS miniseries, and we was funded by the National Science Foundation, and because of that, we had to actually do a little communications research. We had to have a summative evaluation. So when we did the show, I talk about the science, and then we get to this as a problem, and we have Rear Admiral David Tetley and his dress whites who says, yes, the military gets this. When something breaks overseas, when something breaks here, you call on us to fix this. We are getting more business because of this, and we are going to get yet more business because of this. This is a national security issue. So we had Admiral Tetley and his dress whites, and when we got solutions, we had a bunch of Texas ranchers, and we had Marines. Half of the casualties in Iraq and Afghanistan were fuel and water convoys. The Marines can protect a base. It's much harder to protect a fuel line across an entire country that has some people that don't like you. And when they switch to renewable energy and use that to clean the water, they saved lives. And so we did this in the show, and then we had a target focus group, and the focus group in New York said, we knew all of this, and you guys are sort of militaristic nuts, aren't you? And the focus group in Texas sort of said, I'm supposed to hate you, and that's an admiral, and that's a Marine, and that's my neighbor, and maybe there's something to this.
Sure. So all about identifying the right communicator.
The right
Absolutely.
Communicators make a big... We both know a wonderful scientist named Catherine Hayhoe who is married to an evangelical preacher. And she is a communicator from a different position than some of the rest of us are, telling the same message, but bringing with it her convictions as an evangelical. Most of the evangelical churches are supporting a missionary somewhere in a hot place, and if you want gets past the lack of trust of the science, they actually are more concerned about this than people, because they have firsthand testimony to what it looks like, and the golden rule sort of means something to them too. And so having a full range of communicators, having you, right? So there's this fascinating set of maps. Yale Climate Communications has gone out and they have asked America, what do you think of climate change? And if you ask, most Americans accept the science, but not all. And there's a geographic pattern. People in Philadelphia accept the science more than people in very low population areas. So if you ask people, is climate changing? They say yes. Is it humans? Well, it's a little lower. Scientists agree, well, it's pretty low, and that's the purchase confusion. And then the two questions that really matter. Should we look for solutions? It's the same map, but virtually everyone in America says, yes, we should be looking for solutions. This is a great thing. They are happy solving a problem that they deny exists. And then the last one is, are you talking to your neighbor about it? There is no county in America that the average person says they are talking to their neighbor about this issue. None. Zero. And you're here. And you're here.
Sure. I love showing the Yale program on climate change communication maps, absolutely. They had a recent finding as well that parents report, 4 out of 5 parents report that they'd like climate change to be taught to their students, to their children. Right? Thank you, I agree. So maybe we're moving the needle on that front at least. So I'm glad that you brought up the PBS miniseries. This is called Earth, the Operator's Manual. And it's a really rare, wonderful opportunity, I think, for research scientists to be a part of. And it makes me wonder how you got involved in the first place.
Heaven help us, I don't know. So there was a touring outreach thing called Polarpalooza. I think you were just too young to be in this, but you should have been. But it was doing museums and outreach, and I met the Jeff Haynes Stiles, who was the director, did the original Cosmos with Carl Sagan, and then he's done Marsapalooza, and he did Polarpalooza. He's done a lot of citizen science stuff, which was really nice. But he said we should do climate, and we got along, so he invited me to do this. And so I quick wrote a book, and then we turned it into this 3-hour miniseries. And oh dear, it's fascinating. So that step I showed you in the climate, boom, boom, boom. At some point I had written years and years and years ago that the ice ages are like a roller coaster, then that step was like bungee jumping off the climate roller coaster. So Jeff decides we're going to New Zealand to film, I have to go bungee jumping. Actually, there's this big fight about whether it's right to have the scientist bungee jump or we should pay somebody to bungee jump. So they're having a fight about this. And finally I said, look, let's just film it, get it in the can, and then you can fight about it later. So I bungee jumped, and they strap your feet together, and I have a camera here, and I have a camera there, and there's a camera down there, and you toddle up to the edge, and then you address the camera and say, it's like bungee jumping off the climate roller coaster, then you jump off. So. It's a hoot if you get a chance.
So you sound like a pretty active participant there. But you have been known to self-identify as a reluctant participant as well, and it's something we've used in the title of tonight's event. Why have you been reluctant to participate in the climate science public communication aspect?
Right. Well, partially it can be uncomfortable because people will. I can remember talking to an alum who wanted to know all about this, and after we talked for a lot, then he went to our university president and tried to get me fired as an evil liar. And it ruins your day. And you show up in the news, and then you get the "we hate you" emails, and the "we're watching you," and "I hope you suffer," and that's not fun. And I like science. I'm sorry, I got into this collecting rocks and crawling through caves, and I've gotten to go and stand on glaciers, and and I like science, and I'm not socially very good. And I could go through science, and it's sort of getting dressed up and going and testifying to the Senate is.
Sure. Well, I would disagree. You're not socially very good. I think we would all agree you are quite socially very good. But this is fascinating. So, who do you think you've been able to reach quite successfully, and maybe less successfully? Whether it's through the work that you've done with politicians, or it's through this PBS work, or even working with the IPCC as a research scientist.
Yeah, so I had this amazing experience. That I went to Greenland with 10% of the Senate. And
this was when?
This was 2007, not that long ago. But it was, the chair of the Environment and Public Works Committee was a Democrat then. But the chair took Republicans and Democrats, and we went to Greenland. And you close the door on the plane, and you fly to Greenland. And the senators were the most amazing people. And they're smart, and they're interesting, and they're interested. They're good at campaigning. You can see them working each other's staffs. But, but other than that, they knew how the world worked, and they knew the reality, and they knew the science. And they were into it. And when the door opens, and the camera's there, they go right back to script. We live in a world where one misstatement can hound you for the rest of your career. And if you say 1 million words and 10 of them are wrong, you're a failure. And none of us are smart enough to in real time, be glib and funny and human and know how our words could be misused if we say the wrong thing. So they could do script, but behind the scenes, they all sort of got it. And I was at a meeting later and with a bunch of senators, and the truth is, at that point, I think they were a lot more frustrated than we are. Because they were elected to do things. And something happened that was bigger than them, and they found it that they couldn't use their knowledge because something was going on that they couldn't control. And I had this opinion that they're waiting for us to make it possible for them to go back to doing their jobs. And what that is, I don't know. But they're there, and so they've gotten it. We have gotten the information. We've gotten the information to them. They have it in their pockets, and they know. I think the losses are primarily the people we haven't succeeded in reaching with the right voice. And I think everyone who's been able to engage in a respectable way sort of gets it after a while. And that in turn is where you and you and you and you and you and you are so important, because it's just more voices. We had 4 million viewers for the operator's manual. Probably no one in this room saw it. Virtually no one. We got just over 1% of America. It was a huge hit, and that gets you to 1%. Right? You need, but occasionally I hear people using it in classes, and occasionally I hear a phrase go by, and I say, that was Jeff's. That was ours. We did that, and someone got it, and they're using it.
I think that's a really powerful reflection on your experience working with politicians in particular. I mean, you've been doing this a long time. It feels to me that maybe we're at the critical mass for something to happen. And even here in the US, maybe we have an absence of federal leadership, but there has been amazing grassroots response. And a lot of excitement, for example, around the Green New Deal. Many folks are asking about the Green New Deal, and so it's the big hot topic nowadays, right? But not just the Green New Deal, not just policy ideas. There are children's school strikes, for example, all across Europe, primarily. So there seems to be this new energy around action on climate change. Is that spot on, or am I sort of doe-eyed here?
I think you're right. I sort of hope you're right. It's because at one point we all see it now. several of you said you had been to Alaska. You saw the glaciers. They're melting. Virtually every glacier on Earth is melting. We're having less, despite the blizzards in the winter, when you get into the spring, we got less snow. We have less seasonally frozen ground, less permanently frozen ground. We have less river ice. We have less lake ice. We have shrinkage of glaciers. We have loss of Arctic sea ice. We have loss of Greenland. We have loss of Antarctica. I live in a different plant hardiness zone than when I moved in. I can plant different things in my garden because it's warmer. People see the change happening. It's not just them and in the future, it's us and it's now. And at the same time, the answers are now cheaper than what they'll replace in a lot of ways. And the ease of doing this is becoming so much greater. And you can start to see this brilliant future. Right? So we have this amazing history of burning things until we ran out, having a crisis, having a panic, and suffering all kinds of problems. Right? We are Pennsylvania. This is Penn's Woods. And when the European settlers got here, it was trees. They said a squirrel could go up a tree on the Atlantic coast and stay in the trees to the Mississippi. And the first forester of the Commonwealth of Pennsylvania was Rothrock, and he wrote about the Pennsylvania desert. Now, it wasn't a desert, but we had no trees left. Basically, we cut every tree in Pennsylvania. The Pilgrims got to New England, and they landed on Cape Cod at Eastham. And if you know Cape Cod, that's Eastham right there. And they said it was so goodly a land and wooded to the shore. And then in that century, they passed a law that you could not cut your own tree on your own property because deforestation was so extreme that they didn't know what to do. And Pennsylvania had really strict rules about stealing your neighbor's tree. Because Jim White used to say he could always find a couple of old trees because we had crappy surveying and really strict laws that you couldn't steal your neighbor's tree. So very tiny little bits survived. And so we've had this history of burn it, run out, panic, crisis, government intervention, all kinds of problems. And we can fix it. And we're the first generation in all of history that knows that you can farm energy the way you farm food. And that even the people who don't have coal and oil and gas can have energy. And we're the first generation in all of history that knows that we can get off this treadmill, get off of burning, running out, panicking, government intervention. We can do it. We can build an energy system that lasts forever. And it's got more jobs, and it's got more energy, and it's got more money, and it will give sub-Saharan Africa what we have.
This question always comes up when we talk about solutions, of course, to climate change. And I like that you're talking here about the individual, the importance of the individual as a decision maker. One audience member asks what the one thing each of us can do each day, or as often as possible, to make an efficient response to global warming.
Yes. I should ask you to answer that after I'm done. So remember that she's going to answer that after I'm done. Okay. She's an expert, right? This is a wonderful thing at the Franklin Institute, is you have real experts here. So yes, vote, talk to your friends, and then if you want to do more than that, pick something. So you can't solve all the problems in the world. But if you sort of pick something that you want to be into, and whether it be improving bicycle lanes or whether it be getting you and your neighbors together and do something with renewable energy, whether it be convincing Philadelphia that they need a few solar cells on the roof, pick something. Whether it be at your church or your civic group and getting them to get serious about them and get them in. You can lose your mind trying to solve all the problems, and you can't solve all the problems. But if we vote and we talk to our neighbors and we each do something, I think we can push it over. So there's this big barrier to a better world on the other side, and we have to build a better world, but on the other side it's a better world.
Absolutely.
So how do you answer that question?
Ditto? Sure. I always land on talk about it. And of course, I reference these statistics that so few of us actually talk about climate change, even those of us that are in the climate change science realm, right? Or maybe we're working for a politician that's talking and thinking about climate change. When I consistently, when I address a room, I ask this question, and very infrequently, you see a large number of hands go up. So always, always I talk about this. And of course, what we're getting at here is collective action. That yes, each of us plays a role, but we all play a larger role when we work together.
Right. And, thank you, and the Franklin Institute is doing things, right? You have educational efforts, you have any of them that you want to highlight so that they're going to make sure they bring their kids in?
Sure, well, I'll reference again our CUSP group. So I have the great fortune of working with the Climate and Urban Systems Partnership here. And if anybody here is interested in how to craft your climate change message, come and talk to me afterwards, or come and talk to one of the wonderful dozen folks up there that keep clapping at me. Thank you. Really what we're interested in doing here is connecting climate change impacts to our personal lives. And of course, asking the next question, what can we do about it? And so thank you, Richard, for addressing that.
Right. So efficient urban areas are actually fantastic ways to solve climate problems. And if you can make your city work, you have relatively low impact, you can do wonderful things. And so groups such as CUSP are working on how do we make these cities work. And this is really important.
Absolutely. Along that same line, we have another sort of technology-specific question. What do you think is the most important technology in the past decade that will positively impact climate change outcomes?
Yeah, most a single one in the last decade. I don't know. It's this fantastic success in driving renewable prices down and the things that go with them, the batteries, the LEDs, and what have you. We had windmills a long, long time ago. Right? Abe Lincoln, before he's president, Abe Lincoln is on the stump saying we need engineers, we need inventors. Lincoln's the only president who ever held a patent for his own invention.
No kidding.
And so he's out there saying we need inventors, we need patents, and they said we need wind. We got to do wind energy. And then we did, right? And all these poor farms out there in Illinois and Nebraska, and they put up a windmill to pump water for the cattle. And then people started adding lead batteries and generators so that farmstead could have a little light of an evening. And then the government helped kill it. Because between the world wars, we had rural electrification and the TVA and things such as this. So we build some dams, we build some coal plants, we help groups bring the power. And what do? You pay for lead acid batteries and a generator and a windmill, or Uncle Sam is standing at the door with a wire. Which would you like? And so we had wind, and then we sort of made decisions as a group that did bad things to wind. But now we're at the point that was a little bit of wind. These things that they're putting up now really work. Lots of megawatts in one thing. The return on investment of wind now. So you spend some energy to build a wind turbine to get energy back. You spend some energy to frack the ground to get gas back. The energy return is better on wind than it is on fracking now, is my understanding. The recent statistics are, and it's starting to be this way for sun too. The new fossil fuels are not nearly, when Colonel Drake drilled his, he drilled where oil was leaking out of the ground. It was pretty easy to get oil out of the ground. But it takes a lot of investment now to do that because we've used up the easy sources. And so now it's to the point that the wind is doing this. What really is going to do it, though, is going to be some batteries, it's going to be some wind, it's going to be some sun, it's going to be some thinking about. And then it's going to be a whole bunch of really bright engineers that learn how to weave this together, stabilize it, make it optimal and efficient. It's going to be weather forecasters who tell you if the cloud's coming over and you can tweak the grid a little bit. And it's all of this brilliant stuff that's coming to use our knowledge to make this resource efficient.
It's interesting, we don't often pair that conversation, the next emerging technology, with sort of the boring back-end stuff, the data management, optimization, et cetera. Stuff that we maybe geek out on, maybe a few of us.
Yes.
But okay, so a lot under the hood as well.
A lot of under the hood, and I think that's really where the action is in a world of we'll get a coal plant, we'll run the thing, and we'll have some gas sitting around that we can spin up if we really need it, and then we're done. We don't think about it. We just, right? The opportunities to build something which is actually more resilient, so it won't have the 2003, we had that horrible power outage up here because the system did break. How do you build something that's more resilient, something that would be harder for someone from outside to hack, and something that weaves in power sources the way the internet? You can be a user, you can be a producer, you can be both. It's distributed and it's resilient and it's partially crowdsourced. We're going to see a future where you have an electric car and you decide that you don't usually use the whole range, and so you're going to be part of the storage that stabilizes the grid. And when you park your car, you plug it in. And when electricity's cheap, you buy some and you put it in a battery. And when electricity's expensive, you sell it back. And all of a sudden now you're making a little money off of stabilizing the grid. You could do it.
So a lot of opportunities certainly on the horizon. So we are winding down here, so I'll just leave one last question on the table here. And it's that you've been going for so long in this space during different political administrations, different funding scenarios, et cetera, et cetera. What has kept you going?
Yeah, so I am a believer. I am a father. We have a middle school science teacher and a college teacher. We have a granddaughter who was born on February 22nd.
Congrats.
And while I'm over here talking to you, my wife is out hugging the granddaughter. So this is not, sorry. And that's a lot of it, because the bright future is out there. We are at a pivotal point, we're at a cusp, that over the next decades, if we use our knowledge, we can build a future which is, for our granddaughter, which is brighter than anything's ever been. We actually can. There is pretty good evidence that people have fought each other over fuel in the past. We can build a world where everybody has energy, where our 100 people helping us do what we do, that equivalent of energy, that 10,000 watts per person, we could get it for the world. If you wanted to replace every bit of energy used by every human on Earth with room for growth, you can do that with existing solar in a little square that sits in the Sahara. Not the whole Sahara, not anywhere near that much. It's sort of 500K on the side. Is more energy than everybody on Earth uses. If we get 1/100th of 1% of the sun is what humans now use. 1/100th of 1%. 0.0001. Right? And if we get 0.0002, we can double our energy use.
So the technological opportunity is there.
The opportunity is there to give everyone the kind of power that we have, to help desalinate and pump. If you have a lot of water, a lot of energy, you can have a lot of water. And you see that Israel is doing massive desalination now, but it takes a lot of energy, but everyone could water their deserts. The possibility for us the people are here. The possibility for us to give them good lives is there.
Opportunistic possibilities rooted in the golden rule.
There you go.
Please join me in thanking Richard Alley.